Okay, we're back, and we were dealing with Ray's question on the previous segment, and one of the things he mentioned before his question was the idea of a fresh aspirin carried with you, and there's been many of studies that show that if you think you're having a heart attack, we give one aspirin and a beta blocker. Obviously, you don't keep a beta blocker in your pocket, but obviously the aspirin is a mechanism. It is a nonsteroidal. It is a probably the only nonsteroidal which actually alters clotting as opposed to the other nonsteroidals which actually may enhance clotting. So the aspirin molecule does render, once it connects to a platelet through a antithromboxane mechanism, it basically renders that platelet inactive for the rest of its life. So any platelet that is produced by our body, and our body produces thousands and thousands of platelets every day, those platelets, once they're touched by aspirin, they are rendered inactive. That being said, regular use of aspirin is pretty much one of those things that you can decide to do or not to do. I personally believe if you're wanting to do that every day, a baby aspirin is the way to go. If you're taking aspirin for, let's suppose, a non-steroidal effect, like an Excedrin for headaches or arthritis, I encourage you to take 3 aspirin at the same time as opposed to taking 1. The reason behind that is there's a mechanism in our liver called the zero order kinetics, and what that means is that with 3 aspirin twice a day, you turn aspirin into a 12-hour nonsteroidal because it doesn't get degraded. It overwhelms the degradation system in the liver, and it actually makes that aspirin last basically 12 hours. And the aspirin molecule, unfortunately, and it should be enteric-coated. It's very important that you take enteric-coated aspirin because aspirin as a molecule, once it hits your stomach, it basically turns from a acid molecule, which, as from basic chemistry, has an extra hydrogen, or it's an oxidizer, so to say, and it turns that into a neutral molecule in your stomach. So that means it can pass through the parietal cell, or the gastric cell, and if it passes through the cell membrane, because it has no charge, it accumulates inside the cell. And once it accumulates inside the cell, then it turns back into an acid. And when it turns into an acid, then it all of a sudden becomes, it lowers the pH of the gastric cell, and the cell lyses and ruptures. And so there have been actual studies that show that you can place an aspirin on a piece of stomach tissue, and it will just basically burn its way through that particular stomach cell. That being said, that's not necessarily how ulcers develop, but certainly is one of the causes, because your stomach is usually moving, trying to keep that aspirin away from that. But over time, aspirin and nonsteroidals do interfere with what we call prostaglandin synthesis. And as I've said before, there are good prostaglandins and bad prostaglandins, and the good prostaglandins maintain your stomach lining. So when you take Motrin over a long period of time, it denudes or limits that protective lining, and also interferes with renal blood flow. So again, that's digressing away from the reason to take aspirin, but it does interfere with platelets, and it can, through its nonsteroidal effects as well as other effects, can be very helpful for that. And if you're taking aspirin and Aleve or Motrin, you may offset the two, meaning aspirin's effectiveness as a blood thinner becomes reduced when exposed to other nonsteroidals. So keep that in mind if you're trying to do that. try and limit your use of nonsteroidals or separate them as far apart as possible. But the nonsteroidal effect is not on the platelet, but it's on clotting factors. It's on other issues other than the aspirin. So there are two parts of the clotting cascade. There's the platelet, and then there's clotting factors being made by the liver and other supporting tissue. So when you have that's why people who have end-stage liver disease basically will have abnormal clotting parameters because their liver is not making those parameters. If you're taking Coumadin, which is a blood thinner, which we give for people with blood clots either in their legs or they have atrial fibrillation of the heart, those types of things to prevent clots from forming, that interferes with a clotting factor, and that can be reversed with vitamin K. The newer drugs like Eliquis and a few of the other ones, they interfere with other clotting factors, and they cannot be reversed in the first 24 hours. You have to wait until your liver makes more of those clotting factors. So it makes them a little bit more dangerous in that respect, but a little bit better that you don't have to watch vitamin K in your diet. With that being said, I had a patient that came in the other day had some blood areas on his skin, and his INR, which is what we call international units for measuring how thin your blood is on Coumadin, was at 22, and the normal is 1. And when you're treating with Coumadin, the normal value that you want is between 2 and 3, depending on, unless you have a mechanical valve, then it's 3.5. So this gentleman was 10 times the so-called legal limit for taking Coumadin, and that can be very, very dangerous. So we're gonna talk a little bit about this. Ray had called in the last show and brought up the question about Hantavirus, and as you know, we have been plagued in this world recently by even more virulent and more strange viruses that have come out, and every time there's a new one, we tend to get a little more nervous about them. And the newer viruses that are coming out that we're starting to see are these what they call RNA viruses, and RNA virus single-stranded are probably these are very dangerous viruses, and let's go over a few of those that we've seen so far in the world. HIV is an RNA virus, as well as we talk about the Marburg virus and the Ebola. Those are RNA viruses. Now, Ray mentioned Hantavirus. Well, Hantavirus is an RNA virus, as well as the new one, which is now coming out, MERS, Middle Eastern Respiratory Syndrome. So these RNA viruses are very virulent. They basically are transmitted through different vectors. But as we are expanding our so-called human population into other areas, we are now being exposed to these types of viruses, which are usually living in animals that we tend to be associated with or tend to encroach upon their territory. So for those of you that like the vindictiveness, I heard one speaker say a long time ago that we eat cows and then we kill cows and they kill us through heart disease. Well, as we go into these other areas and encroach upon these natural environments, we now are exposed to things that we've never been exposed to before. Such as Ebola. Ebola was a virus that lived in Africa in bat caves, and it wasn't until we would go out into those particular caves and get infected through inhaling or through contact with that particular virus that we would come back and incubate that and spread that out into the population. And such is true with HIV. If it wasn't for the highway across Africa, HIV might still be in a remote area of Africa, but we brought it out of the jungle into the world's population, and now we're dealing with it and best we possibly can. So Hantavirus is a virus that is well known, and I think I have a slide. We're probably going to be going to break in a few minutes, but we can bring up the first slide about Hantavirus, and as you can see, it's not like the haunted spelled. It's spelled Hantavirus, but it normally the virus infects mice and rodents, but doesn't really do anything to them. But what happens is that we become exposed to the rodent urine or feces or saliva, either through bites, and usually it's an aerosolized type of thing, or they can particularly bite you. So if the mouse or the rodent is infected with the hantavirus as it spreads through its community, and we get exposed to that, then we certainly may become exposed to that. Now, there are two different types of illnesses associated with the hantavirus, which is the Pulmonary Syndrome, and also known as the Hantavirus Cardiopulmonary Syndrome, called HCPS. And then, but it is again a rare a case, and one of these things that comes up is it just comes up suddenly, and it basically infects those people, and then it usually goes back down because of where the mice are that are infected can infect those particular people. So and infecting of human to human can occur as before your body can build up any type of immunity, as we're shedding virus through saliva and secretions, things of that nature. Then you may be able to get that. And a little bit of interesting about, it's not named by the guy who found it, but it was named by the Hanta River area in South Korea, where an early outbreak was observed, and it was later isolated in here in the 1970s. So we're going to go to break, and when we come back, we'll bring up some more of those slides and talk about some interesting stuff about virology. Thank you for tuning in.